In physics, we use the kinematic equations to describe the motion of objects in uniform acceleration. For instance, this guy, who runs this much. The quantity d, or displacement, describes how far the object moved. The quantity t, or time, tells us how long it took for the object to finish a certain course of motion. The quantity v sub I, or the initial velocity, tells us how fast the object was moving in the beginning of the course of its motion, while the quantity v sub f, or the final velocity, tells us how fast the object is moving at the end of the course of its motion. While traveling, an object can change its velocity, and this can be described by the acceleration. A positive value for a means the object has sped up, and a negative value means the object has slowed down. We'll be using algebra to move and isolate variables from one side of an equation to another when solving problems in kinematics. So, if you need to brush up on your algebra skills, please do so. Let's try solving a sample problem. Monica, currently jogging at 3 meters per second, decides to speed things up until she reaches a speed of 5 meters per second. If her acceleration was 4 meters per second squared, how far was she able to run? Let's list down our given. She has an initial velocity of 3 meters per second, final velocity of 5 meters per second, and an acceleration of 4 meters per second squared as she sped up. In this problem, we are asked to find the displacement, or how far Monica was able to travel. It is important to identify the right equation to be used based on what was given to us and what is being asked. Looking at equation 1, we see that the displacement, the quantity that we are looking for, does not appear in this equation. Therefore, we will not be using equation 1. Displacement appears in equation 2, but here, the motion time must be known in order to solve for the displacement. Hence, we will also not be using equation 2. Meanwhile, the quantities in equation 3 are all given to us and will enable us to calculate for the displacement. Hence, we will use equation 3 to calculate the displacement. Now this is where one's algebra know-how will be tested. To solve for the displacement, we must subtract v sub I squared on both sides of the equation, leaving us with just 2ad on the right-hand side. To completely isolate displacement, we divide both sides by 2a, giving us an equation for displacement. Substituting the quantities that were given to us, we get d is equal to 2 meters.